All right, greetings, scholars. Here we're going to be taking a look at section 2.3, Models and Applications for College Algebra 2 for Morris Brown College, spring of 24. A few objectives here. In this section, you will set up a linear equation to solve a real-world application, and use a formula to solve a real-world application. Can't get my words out today. Uh-oh. At least I think it's just not showing. I know. Okay. Let me see. So we're translating from sentences to symbols, right? So one number exceeds another by a, right? So those are just some examples of like how to show up. I'm just going to let you kind of peruse that on your own. And then given a real world problem, model a linear equation to fit it. Identify any known quantities, assign a variable to represent the unknown quantity. If there is more than one unknown quantity, find a way to write the second unknown in terms of the first. Write an equation interpreting the words as mathematical operations, and then solve the equation. Be sure the solution can be explained in words, including the units of measure. Okay. So in this example, we're asked to find a linear equation to solve the following unknown quantities. One number exceeds another number by 17, and their sum is 31. Find the two numbers. Okay. Oh, good chocolate. Let me grab this. Let me grab this, and I think we're Gucci. Okay. So it says one number exceeds another number by 17. So x or y equals x plus 17, right? So we could say something like y equals x plus 17, okay? And then if you add the two numbers together, their sum is 31. So that means x plus y equals 31. We have two equations, two unknowns we can solve. So now notice the first equation we've already solved for y. We can take that and substitute it into the second equation. So now the second equation becomes x plus y equals 31. But again, our y is going to be that x plus 17. Since we don't have to distribute, we can actually just lose the parentheses here. So then x plus x gives us 2x. If we subtract 17 on both sides, 31, 21, 20, what is that, 14? No, let's try that again. 21 minus 7, 20 minus 6, I guess 14. Yeah, okay. And then divide both sides by 2, x equals 7. Okay. So then we can use this, plug it back into like the first equation to solve for y. So y equals 7 plus 17. So then y equals 24. So our claim is that these are the two numbers. So notice if we add 17 to 7, we get 24. And then 7 plus 24 is 31, right? So these two numbers work. So it should be 7 and 24. So now you see it there. So setting up a linear equation to solve a real-world application. There are two cell phone companies that offer different packages. Company A charges a monthly service fee of $34 plus 5 cents a minute per minute of talk time. Company B charges a monthly service fee of $40 plus a 4 cents per minute talk time. Okay. Writing a linear equation that models the packages offered by both companies. If the average number of minutes used in each month is 1160, which company offers the better plan? If the average number of minutes used in each month is 420, which company offers the better plan? How many minutes of talk time would yield equal monthly statements from both companies? Okay. Let me see. So a base fee of 30. So we'll focus on company A, and I'll just abbreviate it like this. So a monthly service fee. So we'll say this, the package for company A is going to be what? Let me see. A monthly service fee of $34. So it's a flat fee of $34 plus 5 cents per minute of talk time. And so I guess we'll let T be the minutes of talk time. Okay. And then company B their package, the package for company B, a flat fee of $40 plus 4 cents per minute of talk time. Okay. So write a linear equation that models the packages offered by both companies. Okay, so I think that will suffice. So then if the average number of minutes used in each month is this, which company offers the better plan? Okay. So what's the charge for company A if we plug in 1160? So 34 plus 5 cents times 1160. Let's just do it here. Now what I'm going to do is go to my y equals, and I'm going to put company A into slot 1. 34 plus 5 cents times x. Okay. And then company B I'm going to put in slot 2. 40 plus 4 cents times x. Okay. So then if I go back home, let me call in these functions. So to call on the functions, what I'm pressing, left of the clear button is the button that says VARS. I think it's short for variables, so I'm going to click there. I'm going to go to the right to go to Y variables, number 1 for function, and I'm calling on the first function first, right, for company A, and I want to evaluate that when X is 1160. Okay. So it looks like that bill is $92 for that month. I'm gonna just say per month. Okay. And then the package for company B at 1160. And I'm just gonna put the result there. So I'm gonna go to variables, Y variables, function, and I wanna call on the second function so I can pull up company B, and I wanna evaluate it when X is 1160. Looks like it's $86.04. And 40 cents, okay, per month. So at that, with those number of minutes used, it looks like company B has the better rate. Okay. Kind of running out of space. Let me see. So this was part A, this was part B, and let me give myself some space. I want to duplicate this, duplicate, and clear. Okay. Okay, so then I think we want to repeat that, but say the number of minutes used is 420. So for C, if we consider package A, if we use 420 minutes per month, right? So then I'm just going to call on that first function. I'm just doing recall and change the 1160 to 420. Okay. So that bill looks like it's going to be $55 for the month. Okay. And then the package for company B at 420 minutes used. $56.80. Okay. So it looks like less than 4, or at 420, it looks like company A has the better package. Okay. Oh no. Oh, okay. Yeah, it should be okay. It's gonna have to be. Okay. How many minutes of talk time will yield equal monthly statements from both companies? Okay. So then for D, they're asking us to basically equate these two equations, or set these two models equal to each other and solve. So I'm gonna get a copy from here. Copy. Paste. Let's see. So we want to see when is that one equal to this one. Okay. So I'm gonna, any term that has the t, I'm gonna move it to the left. Any term that does not have t, I'm gonna move it to the right. So I'm gonna subtract 0.04 t from both sides. So on the left, it looks like I'm gonna get 0.01 t. And if I subtract 34 on both sides, it looks like we get 6. So if I divide both sides by 0.1 or 0.01, that's the same as what? Multiplying by 100. So then if we multiply both sides by 100, we get these two companies packages equal each other when the client talks 600 minutes per month. Right? So then if I were like considering these packages, I'd have to decide, okay, do I think I'm gonna talk less than 600? Honestly, I probably would just go for the second package, because it looks like the second one has the better rate long run. Like the second one looks like it's better when you're above 600. And I feel like when the first one has the better when you're below 600, the difference is negligible, right? From the example, like when we did the 420, company A had the better deal, but it was only better by like what, $1.80, not by much, right? So then that way I can comfortably go beyond 600 minutes, and anything above 600, I'll have the better deal, right? And so it can, who knows how many minutes we can use, right? It's just, I personally would go for like company B. Okay, so it looks like they should be equivalent at 600 minutes. Let's see how do we do compared to the prepared notes. Did we get 92? Yeah, $92 a month and $86.40. Okay. I think our models were good. I think we got the same results for B. And we got the same results for C. If the average number of minutes is yeah, we got that. And then for D, 600, right? Okay. And so basically this is what's going on. The equilibrium point is at the 600, and then, okay, so I think company A is in red. When we're below 600, it looks like company A bill is going to be less. But when you speak, when the client goes over 600, then company B's bill is going to be less. Okay. So solving the application using a formula. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer, and he averages 10 minutes an hour, 10 miles per hour less than in the morning. How far does Andrew drive to work? Okay. So the formula here, it sounds like that we're using is distance equals the rate times the time. Okay. So what I'm going to do is make a chart. Let me see. Let's say going to work, or we could say the morning. we could say the morning versus the evening, or going to work versus returning home. All right, and across the top, we're going to have the rate times the time equals the distance. Okay, and so what? Can I do this? Probably not. I didn't do it right. So we're basically making a chart. About like that, looks good. And then kind of like this. I don't know why it snaps out. That always irks me. Like, stay snapped. You know, that's what I need. But anyway, copy and paste. Let's see. Yeah, that looks good. Okay. Okay. So all we did was making a chart, and we're going to compare him going to work versus returning back home. It takes 30 minutes to drive to work in the morning, right? Or let's just do morning versus evening. I don't know. I'm just being indecisive. I don't know. I guess I'm like sleepy. I don't know. It's Monday. I'm like, ugh. The morning versus the evening. Okay. So it takes Andrew 30 minutes to drive to work in the morning. So his time in the morning, and this is going to be in terms of minutes. Wait a minute. Miles per hour less in the morning. Let's actually, instead of doing this in minutes, we need to do this in hours. We need our units to be proper. So this is going to be in terms of hours. This is going to be miles per hour. Those are the units there. And the distance we're going to say are in units of miles, right? So if it takes him 30 minutes to drive to work in the morning, that's what, half of an hour. So we'll say 0.5 hours. He drives home using the same route, but it takes 10 minutes longer, right? So instead of 30 minutes, it takes 40 minutes. 40 out of 60 is what? 2/3. So here, let me do fractions. So this one is 2/3, and this one is half an hour, right? Because if it takes him 30 minutes going, it takes him 40 minutes coming back. 40 divided by 60 is 2/3, right? 10 miles per hour less than in the morning. So we don't know his rate for the morning, but we do know that his rate in the evening is slower by 10 miles an hour. So it's going to be his morning rate minus 10. Okay. Miles per hour times hour gives us miles, right? So with this information, his distance in the morning is going to be half of R. And then his distance in the evening is going to be 2/3. So we're basically multiplying 2/3 times R minus 10. And we know that he takes the same route. So the distance in the morning is equal to the distance in the evening. So then we can say 1/2 R equals 2/3 times R minus 10, right? And then solve that equation. We have one equation, one unknown, so we can solve. To get rid of the fractions, let me give myself some space. Let me give myself some space first. I should have a blank. This is slide 13. Copy and paste. Nice. Okay. And let me get a copy of this and paste. Okay. So we're gonna work on this guy. All right. So now we can start by clearing the fractions. To clear out all the fractions in this equation, multiply the left and the right side of the equal sign by the least common denominator. So between 2 and 3, the least common denominator is going to be 6. All right. So we're going to say the entire left side times 6 and the entire right side times 6. Now on the right It takes practice to see this. It's really just times that first one, right? So then 6 divided by 2 on the left, we're going to have 3r. On the right, that's going to be what, 4? 2/3 of 6 is 4 times r minus 10. Now we distribute that 4. Okay. So we'll have 3r equals 4r minus 40. Okay. I'm going to subtract 3r and add 40. So then his rate in the morning should be 40 miles per hour. Okay. All right. So that's his morning rate. So then the distance is half of that. It looks like it's 20 miles. So the distance should be half of 40. It's 20 miles. 20 miles Morales. All right. I'm totally sleeping. I'm not really sleepy. I don't know. I'm just not all the way awake. I don't even know how to describe it really. Okay, and let's check it in the second one as well. Like if we plug in, we said what, 40? 40 minus 10 is 30. 30 divided by 3 is 10 times 2 gives us 20, right? So in either case, we get 20 miles per hour. Oh, that's interesting. Let me see if I can move it. Does that affect anything? Wow. Learn something new every day. Okay. So it looks like the distance that he travels is 20 miles to and from work. Okay, so then 20 plus 20, right? Oh, that's his rate? Yeah. So the distance between home and work is 20 miles, yeah. So note that we could have cleared fractions in the equation by multiplying both sides of the equation by the LCD to solve for r. That's the way that we did it, right? Then multiply both sides by 6. We got the same thing. Okay. So we want to look at a perimeter problem. The perimeter of a rectangular outdoor patio is 54 feet. Rectangular patio. So can we get a color? We don't have it. Oh, there it is. Yeah, let's do this one. No, I didn't want to change that. Oh no, what color was it originally? Oh no. Blue, red, orange. Was it yellow? I don't think it was yellow. Oh, it was black. Dang, I don't want to change it. I just want to use this color. Okay, well, at least I know it's black, so I'll fix that in just a moment. So we have a rectangular patio. Okay, so about something like that. It says the perimeter of a rectangular outdoor patio is 54. So I'll go ahead and change this back to like Amy Winehouse, back to black. The perimeter is 54 feet. Okay. The length is 3 feet greater than the width. So let's call this W from here to here. Okay. And we said the length is the width plus 3, right? So I just made my longer side the length. Okay. What are the dimensions of the patio? Now, if we're talking about perimeter, perimeter is what? We add up the distance around the outside. So then the formula for the perimeter would be what? 2W plus 2L to give us the perimeter. Okay. So I think we can get this down to one variable, right? We can replace L. We can rewrite L in terms of W, and they gave us information on the perimeter. So if we do our two substitutions, 2W plus 2 times our L equals 54, but L is W plus 3. At this point, we have one equation, one unknown, so we should be able to solve. So then we'll have 2W plus 2W plus 6 equals 54. 4W equals 48. I'll continue over here. Divide both sides by 4. It looks like W equals 12 feet. What are the dimensions of the patio? It looks like 12 feet by 15 feet. Okay. $12 by 15 feet. I think we got like one or two more. The perimeter of a tablet of graph paper is 48 inches. The length is 6 inches more than the width. Find the area of the graph paper. So we're working with some paper. I didn't want it to be square. Okay. All right. It says the perimeter is 48 inches. The length is 6 more than the width. So they didn't give us any information on the width, but it says that the length, we'll kind of turn it like this. The length is 6 inches more than the width. So the width plus 6. Okay. Okay. So I think we can do something similar. Yeah, I know that's like, I know that's a bit, anywho. Okay. So let's see. So the perimeter is 2L plus 2W. So 2W plus 2 times L is W plus 6 equals 48. And I think we're, wait a minute. Find the area of the graph paper. Okay. So then area of this shape is going to be length times width. And we'll find that momentarily. We can solve, right? Similar how we did the last one. So if we distribute, ultimately we're going to get what? 4W plus 12 equals 48. So then 4W equals, oh, I don't know if it's going to make it. We're going to try to finish this out. I think it'll make it. We subtract 12, 38, 36. What is that, 9? So if the width is 9, that means our length is 15. So then our area, 9 times 15. 90 plus 45 is what, 135? Square inches. Okay. 135 square inches. Find the dimensions of a shipping box given that the length is twice the width and the height is 8 inches and the volume is this. Okay. So a box, all right. So let's do something like this. We're gonna do something like 3D. Let's copy and paste. Let's put this about like that. Connect these corners. Okay. Okay. Let's go partial. You have anything smaller? I don't think so. You don't have anything smaller? Oh, there we go. Okay, that'll suffice. All right. Looks good. Okay. Now, length, width, and height. The length is twice the width. So let's make this W. It says that the length is twice the width, so L equals 2W, right? And the length is going from here to here. The width is basically going from here to here. And the height, which is what, 8 inches? Let me give myself some space. The height is 8 inches, runs from here to here. Okay? And we're also given that the volume, hopefully my battery makes it, equals 1600 inches cubed. Okay? So let's kind of work over here. The volume is going to be length times the width times the height. So that's going to be 2W times W times 8. So that's going to be 16W squared. But then that's equal to 1600. So then W squared equals, what is that, 100? Take the square root. Normally it would be plus or minus 10, but a negative distance doesn't make sense in this context. So we're just going to take the positive result. So W should be 10 inches. Okay. So it's going to be 10 inches by 20 inches by 8 inches. Should be the dimensions of the box. Okay. 10, 20 by 8. 10, 20 by 8. Note that the square root will result in a positive and a negative value. However, because we are describing width, we can only take the positive result. All right. So I think we got the same thing there.